Hello everyone and welcome to the Java solution for the remove element problem found on leetcode.com. A full description of this problem can be found on LeetCode in the link in the description. It also can be found right here in the source code in the comments section, which can be retrieved from the GitLab repository. The link to our GitLab repository is in the description as well. Before you start before we begin this video, if you have not already seen the previous video for the JavaScript solution, I encourage you to watch the first few minutes of that video. We cover the description as well as the algorithm, which is reflective of this code. Some of the code from the JavaScript solution is very similar to the Java solution that we're seeing here. But without further ado, let's go ahead and review our Java solution for the remove element problem. You see that we have a remove element method. This is the method that we were asked to implement from the description on leetcode.com. We received two arguments, an array of numbers and a value that we are tasked to remove from the array of numbers that we are passing in. The return value is going to be an integer k, which is going to represent all of the numbers that we did not remove. So in other words, all the elements of the numbers array that did not match the value that we are tasked with deleting or removing from the array. Now, if you've seen the video, the previous video for the JavaScript solution where we talk about the algorithm, we don't necessarily delete the items from the array. We just simply substitute them with a value. In this case, -1. It can be anything that you want, really, but we chose -1. And when we delete, quote unquote, a element, we then take that -1 and we move it all the way to the back of the array. And we do so by using a series of swaps. So from the index of the number that we are deleting, and really we're substituting, we then swap that number with the next number all the way down to the last element in the array. There's some other factors here, but I don't want to go too deeply involved in that. We discussed that in the previous video in depth. But the main idea here is that we're going to return k, which is the number of elements that we did not delete from the array. One additional point that I'd like to make is that k initially starts off as the length of the entire array of numbers that was passed in. And as you can see here, we sort of decrement that number when we're doing a deletion. So we're kind of working a little bit backwards here. We're usually used to incrementing things from 0 on up, but we decided to do things a little bit differently and move backwards. In any case, we still get the correct answer, as we'll see once we test the code. Here we have our judge function. On leetcode.com, the description for this problem gives some pseudocode for how your program will be evaluated, and they call it a judge. So we decided to implement the judge in this program, and we're going to test our values or test our code using this judge program that we're seeing here. It's going to call our remove element, and then it's going to test whether or not the number of elements that's in the numbers array, which of course is the number of elements that we did not delete, and we're going to compare that to the expected nums length. Now, the expected nums is just an array of all of the numbers. It's just an array of all of the elements that we expect our nums array to have after we call our remove element method. We sort the numbers, interestingly enough, because we're going to do, if you look further down, a element to element comparison using the same index. So if the numbers are not sorted, then it's quite possible that we can have numbers that don't match up. So we want to make sure that we sort nums, our nums array, and then we go ahead and we compare it to the expected numbers, which is also pre-sorted. If we look at the main method here, you see that we have an instance of remove element created, and you see that we have a two-dimensional array of test values, and each element in that two-dimensional array is another array that contains 3 elements. The first element is going to be corresponding to the nums argument when we call our judge function. The second argument is going to be the value that we're going to remove from the nums array, or the very first element of the array here. And the last element of each of these arrays is going to be another array, which is the expected nums, as we've seen in the judge method above. And here we just have some code that just iterates over our two-dimensional array of test values, and it calls the judge function for each one. Now, before we go ahead and execute this, our judge function does some assertions here, and as you know, assertions should stop the program from executing should we find something that isn't quite right. So let's go ahead and run this code in IntelliJ and see what we have. Okay, and we have no issues, as you can see. One quick point that I'd like to make about this before we look at the LeetCode results. This minus EA here. So if you're going to run the code, make sure that when you run your code that you pass in that minus EA JVM variable. It stands for enabled assertions. If you don't have it, what will end up happening is the assertions themselves will almost end up being ignored. So if you run into a problem at any point that you have your assertions being tested, the JVM won't report it, and it'll give you a false sense of security. So at this point, I think we're ready to test our code in LeetCode and see what our results yield. Okay, so here we are in LeetCode with our remove element code that we've seen previously, sort of copied and pasted in here. Obviously, the judge and the main methods are not here. So let's go ahead and run it and see what happens. Okay, LeetCode's doing its thing. Be patient. Okay, so the first two test cases seem to work. So now I think we're ready for a submission. So let's see what happens there. Okay, we have an acceptance. So let's take a look at our performance. Amazingly, it beat 100% of the solutions for CPU time. That is very, very, very good. I've never had any sort of results like this before on any problem in LeetCode. So that's definitely a first. Our memory consumption could be better, as it only just under 32% of the other solutions that are out there. So I think that there's some room for improvement in this code. So as always, if you have any improvements on the design or any solutions or any comments, please leave them in the comment section. And I truly hope that you enjoyed this video. As always, if you have a chance, please like and subscribe to the channel. That'll help it grow. And as always, thank you guys for watching, and I will see you on the next video.